Hey, and welcome back to another Master Classic math video. Today's video, your host, Shalongo, is brought to you by, per request, one of the OG scholars we have this year, Sean. Sean, let's get into first question. I actually took an L on the first Q, so you're already seeing at the bottom here, oh, he's got a gray. It's totally okay. I'll bounce back. I'll level that up. What do we want to do here? We want to factor this expression, and this one kind of looks kind of confusing. This is kind of unfortunate that this is the first one it gave us. But we've got to factor that, and the first thing I want to do is this a perfect square example or is it a difference of squares example? If it's a trinomial, it's perfect squares, so three things being added. So we got 1, 2, 3. Cool, this is a perfect squares. The other way I would know that is just by looking at the formula it gives us. That's a perfect square in factored form. Okay, cool, I know it's a perfect square example. So that's important only because then I know at the end I'm going to have something squared here. I already know that because it's telling me that's the form it's going to be. And it's minus. It even tells us it's going to be minus. So I can go ahead and put the minus down. And then looking at the expression, and I'm going to go ahead and use blue here. We just have to figure out what u squared and v squared are. U squared is the first term. So our first term is x plus 4 squared. That's what u squared is. Our v squared term is our last term here, right? Would be the last term. Which in this case is 4y to the 10th. And we need to figure out what u and v are. We know what u squared and v squared are. In order to figure out what u and v are, we've got a square root. So we got to take the square root of these. Cool. That's really easy. The square root of x plus 4 squared. These are inverses of each other. Another way of thinking about that is you divide exponents when you take the square root by 2. So 2 divided by 2 is 1. So we're just left with x plus 4 to the first power, which is the same thing as just x plus 4. Let's be honest. And then we've got to take the square root of 4y to the 10th. Square root of 4 is 2. And then we divide 10 by 2, which is 5. And that should make sense to you because 2y to the 5th times itself would give us 4y to the 10th. So now we know what u and v are. All we have to do is substitute u and v. Well, first we got to find them. Boom, boom. Okay. I've got option C here, matching up, making sure, good. And now we're just substituting in what u is, which is, in this case, and I'm going to put this one in parentheses because it's a binomial for the first term. So I put it in parentheses. So we got u, right, just like it asked us to. Figure out what, u minus v. We know that u is x plus 4, so I'm substituting in that down here. And then the v portion here is 2y to the 5th. And I'm substituting that in right there. And then I've got the squared because that's the formula for the expression that we're using, right? Perfect square. Boom, done. All right, Q2. Is it a perfect square or is it difference of squares problem? I'm looking. Cool, it's difference of squares. How did I know that? Because it's a binomial. But it also tells me that's the expression. And we know that that's the expression that goes with difference of squares. And so we know that this is a difference of squares problem. We know that u squared is 25x squared. And we know that v squared is 36y to the 8th. We don't need to include the negative here. The negative is part of the difference portion. So if we just want to know what v squared is, it's the term behind the negative. I know that sometimes can get confusing. Square root of 25 is 5. Square root of x squared is 2 divided by 2 is x. So square root is 5x. Square root of 36 is 6. 8 divided by 2 is 4. There's our u, there's our v. Now we're just punching in our, well, we got to find it first, right? Boom. Good. And now we're just using this formula here that's giving us u plus v. Right, I'll write it again. U minus v. Cool. This is going here for the u's. And this is going in for the v's. I've got one of the factors in here, right? I've got the u minus v. I just wanted to show you this. A little quick trick. Control copy it. Control paste it. Switch the minus to a plus, right? So we've got 1 plus, 1 minus, but it's the same binomial written twice. That's the only difference there. And on to Q3. Looking at it, it's telling me, okay, cool, we want a perfect square here. And I knew that because the expression's asking us to write it in. I gotta figure out what u is. I don't know yet. I know u squared is x minus 5 squared. And I know that v squared is the last term, which is y to the 6th. I want to know what u and v are, so I've got a square root. This is going to be x minus 5. That was easy. These are inverses again. Here, I just divide, or I just figure out what the pairs are. Y to the 3rd. Boom, done. And now I'm just putting it in the form that it's asking us, so u plus v, well, squared. Well, we know what u is. Boom, boom, done. And we know what v is. So now we just got to substitute. This is the substituting part. Cool. So now I'm just going to write it. Actually, I'm going to type it. Yeah, I'm going to type it. Before I do though, I'm going to make sure I found the right one. Nope. And this is like kind of confusing here. Just like double check to make sure you got the right one. Cool. I got the right one. And then final answers. This one's a binomial, so again, I got to put it in parentheses. There's the u plus, right? Yes, plus v, which is y to the 3rd. That does not need to go in parentheses because it's by itself. And then don't forget the squared. Whoa. Squared on the outside. I'm done. Just like that. And that's the third example. I think 3 is enough. If it's not, well, good luck.